I didn't introduce myself yet, so I was thinking of doing it here. My name is Juho, Viitasalo. I'm from Finland. I'm an industrial designer. And well, today I will be talking about 3D printing related things. I've been living in Japan for a long time, for several times actually, ever since first time in the 90s, a long time ago. And yeah, I work here in a Japanese company as industrial designer, and usually I'm creating, I'm doing a lot of 3D work. So I do everything from consumer electronics to furniture, package design, all sorts of things in 3D. And not all of that is 3D printed, but, well, a lot of it is at least in the prototype phase of a project. Just to give sort of a quick idea, here's a recent thing I 3D printed. It's a lampshade. So I had a lamp at home that had a kind of a broken glass shade, and so I thought of creating something for it. And well, it's so I love 3D. I've been doing 3D since 3D CAD. I mean, since early 90s, and so I've basically, well, not if every day, not maybe almost every day, I'm living inside some 3D software. So for me, it's kind of fun to create things that I'm seeing on the screen, and then I can print those out and use in my, for example, in my everyday life. Not just something that I would do during a work project. But so I often do these presentations where I talk about 3D printing in general, kind of what's been going on recently, what kind of printers have come out, what you are able to do, something you weren't able to do earlier. For this audience today and the Hacker News concept, I thought of maybe talking about something a bit more geeky, if you will. So I'm not going to, well, I can talk later if you guys want to hear something about recent developments in printers and stuff like that. I can talk about that after my main topic, which is from polygons to voxels. Let's see what that is. Here we have a torus, a donut. And something like this could be very easily 3D printed. Not a very difficult thing to create, but you know, for example, to carve this with your own hands out of some material might be a bit difficult. So let's 3D print this. So if we're 3D printing something like this, the way the printers deal with these objects is the object is sliced. So here, just sort of a rough simulation of the same torus sliced. Well, normally the slices would be much thinner, so you wouldn't be able to see them that easily. But okay, that's a kind of a good representation of what happens sort of internally inside the printer. Now, the file format we use is called STL. This is a very standard 3D printing format. And it's been around for a long time. It's been around since the 80s. And this STL means stereolithography. The first 3D printers that came out in the 80s were these basically buckets of goo that you would then use lasers or UV lights for hardening certain parts of the goo. And so, yeah, so we kind of got stuck with this file format. And here we're starting to get really geeky here. So this is how the format looks like. It's, well, kind of looks like XML, but not. But here we have basically this area which is inside that bracket, the big bracket that I put on the other side, that defines one triangle. So all the 3D printable data is defined out as triangles. Okay, triangles. But there are no triangles here. where, if you remember the slice photo, there are no triangles here. So what happens with the triangles? The printer uses slices. If it were in triangles, this is how it would look like. And that is basically how it looks like when you export the data from your CAD for printing. So what's going on here then? Okay, well let's take a look at something here. So these are polygons. So polygons they're just triangles. They're just dots connected, 3 dots, and they form one flat facet. Okay, and with these triangles you can create any kind of surface. It looks a bit rough, but yeah, you can create any kind of surface using just triangles. Now, as an industrial designer, I'm not using polygons, triangles as the starting point. I'm using something called NURBS, which is high quality, there you go, non-uniform rational B-spline. With using these kinds of curves, you can create beautiful curvature. Not just in 2D, but obviously in 3D. So you can make beautiful geometry, which is at the same time very accurate. Like we can go down to microns in accuracy or in tangential continuity, for example. So for example, when you're designing a car and you're looking at the hood of the car, you don't get any twitches or glitches in the way the light flows on the hood of the car. However, this kind of data cannot be used as it is for printing. We have to convert this kind of beautiful NURBS data to polygons. This is called tessellation. And it can be very rough. It can look very rough. So you're losing a lot of detail. Okay, well, we can control the tessellation, how that works. So we can make things smoother. But as we increase the amount of polygons, we're starting to hit size problems. For example, many of the printing services online, they only you can only use a file, upload a file up to 64 megabytes or 1 million polygons. And actually 1 million polygons is not, it's not something too large of a number when you're creating some very intricate objects and then converting those to polygons. You can hit that limit fairly easily. And another issue I want to bring up is if we take a closer look at this kind of polygon-based object, let's just remove some part of it there. So for the software, that's a solid. Although there's nothing really inside of it, but it's considered to be a solid. And well, the physical objects that we use and surround us, they are solid. So you, for example, you couldn't have something like this that is open like this. Another thing here is every surface, every polygon facet has a direction. So with the direction, we now know what is the exterior of the object. So if, for example, if one of these facets is flipped and the direction is inwards, we can no longer print this object. The software considers that to be a hole in the mesh. So this kind of direction problem can cause a lot of hassle for certain people who are, let's say, somebody who is not so well versed in 3D CAD. Some of the software kind of takes good care of that without the user having to really pay any attention. But some software is very strict. And you absolutely have to make sure that you're basically on top of the situation yourself. Well, so the polygon, this polygon-based printing it's good for certain things, but lots of people have started wondering if this is really the thing we should continue with 3D printing. And, well, what can we do then? If we don't do this, what can we do? There's now a thing called voxels that I want to talk about. So, what are they? Well, this is a pixel. Pixel is a two-dimensional thing. And this is a voxel. So voxel is a three-dimensional pixel. Some of you might know some three-dimensional pixels. So actually there are lots of games that already use voxels. For example, well, Minecraft uses a editor, a voxel-based editor, but then the game itself treats apparently the graphics as polygons. And Crysis, the game Crysis has, well, the terrain, the environments are partially created by voxels. Voxels can be used as pixels in a way that you can do anti-alias-like things. So I'm going to come back to this later again, but in some cases you're able to achieve higher quality with voxel smoothing than you were able to do with polygon-based data, for example. So let's say that this is now, this is a detail from one of our slices. So all the voxels are now, well, let's say pixels. The pixels are put into slices. Whatever data you create, that gets sliced up automatically by the software. And those slices, well, okay, I only have 5 here just for the sake of clarity. But when you have hundreds and thousands of layers of pixels, now suddenly you have voxels. So now, if you remember the previous parenthesis I had on the STL syntax, this is now the new kind of syntax. Instead of having this long repeating loop of triangles, as the STL file has. And yeah, just once again, this is not anything new. In a way, already games and other some other software are using this. So let's again, a geeky thing, but let's look at the syntax. So, well, one of the problems I forgot to say earlier was that one problem with voxels is that there hasn't been a standardized file format. Even though, in theory, it's very understandable how it works, but there's no file format. So, as the first example, a big 3D printing company called Shapeways, they've created a format called SVX, which is called completely open format, simple voxels format, and which is, well, actually very short. This is really the only thing you need to write as the manifest, because really everything happens here. So you have a set of PNG files, black and white, 8-bit, for example 8-bit, PNG files that are in a folder. The other stuff can be metadata and all sorts of things. Mainly, you just have to pay attention to the grid sizes, so you get the correct amount of voxels that you want to use. Now, another interesting thing about voxels that, for example, the polygon-based STL cannot do is, again, already mentioned here, density. So we have all the PNG files in a folder called density. What does that mean? It means that in voxel-based 3D printing, we can have different channels. So the so-called density channel, which is the shape channel, which is the actual meat and bones of the printable data. But beyond that, we can have a different set of slices for color, for material, for the future multi-material printers can just use this one file for printing a product, an object. If we were to do materials with STL, we now need to have several files and somehow try to make those files together, make everything match, and it would be kind of a hassle or a very big hack. So in my opinion, voxels are much more better, well, suitable for this kind of multi-material thing of the future. And then you can basically define all sorts of other channels, whatever the future will bring along. ISO values, all sorts of surface parametric things, etc. But at the moment, we're so far only using the density channel. Another sort of format, or this is a software. There's a very new brand new software called Monolith. It's free. It's developed by a couple of guys from Harvard, and it's a software meant for voxel-based modeling of multi-material objects for 3D printing. So if you're interested, please try it out. It's unfortunately at the moment real-time voxel editing on your computer is very, very resource intensive. So you will need to offload a lot of this work to your GPU. In some cases, OpenGL is better. In some cases, something else is better. But what this is kind of promising for the future is this kind of not just multicolor, but multi-material print. So once those kinds of printers come more common, that is, of course. At this moment, you can do multicolor printing, but that's completely, again, a different kind of sort of not very well future-proof system. So once again, I'm going back to this just to, so again, from a industrial design point of view, voxels are maybe still not a good starting point for creating the original data. If you're an industrial designer, for example, and you need very high accuracy. But because even polygons, there's also the same thing with polygons. It's not really accurate enough for product design, for example, where you have to produce tooling, molds for industrially produced parts, for example. So, however, sometimes when you're converting NURBS data into polygons, you're getting problems that you have to somehow fix. Some kinds of problems are caused by software. Sometimes you kind of have to help the software and actually construct small parts of the polygon mesh by hand sometimes. This kind of hassle, again, in my opinion, I hope will be going away when it's more prevalent in all sorts of CAD packages to just automatically just export from NURBS to voxels, completely skipping over the polygon tessellation. And well, as I'm talking about industrial designers, this is how this will apply to everybody. So, for example, 3D animators, 3D artists, who have the wherewithal to make good data, they can go from NURBS or Bezier or polygons through the conversion process to polygons or voxels, whatever will suit them best. Same for industrial designers and engineers, like I said. But what's very interesting here is that the people who are doing 3D printing as a hobby, for example, the enthusiasts, this voxel technology will probably open a lot of new possibilities for these kinds of people and basically encourage a lot more people to adapt 3D printing. Because now you can start with voxels and you're working with the same data you're going to output. So there won't be any kind of weird setbacks here in between. So the STL file is not going to go away. It's going to be around, and the sort of polygon tessellation route for 3D printing, that's not going to go away, at least not immediately. And it shouldn't, because there are probably many cases where that will still be the best way to produce something. It's just like sometimes when I'm talking to industry people about 3D printing and they want to know if they should start doing more and more production through that technology, I often say, no, not necessarily, because some things it will make more sense to use traditional production techniques. In some cases, it will make sense to use 3D printing. The same thing will happen here, that you can still use the normal technology, but especially for certain use cases or certain kinds of users, this kind of voxel-based data structure will be much easier. And this is going to also, well, change the way some printers evolve, how companies develop their printers and services from now on. Hopefully to a much more adaptable and flexible way that's more fun for everybody to use and enjoy. So, thank you very much. That was my sort of look into what's going on and what might be happening in the near future. Thanks very much.
I have a question first. You mentioned like Voxel usages potentially like anti-aliasing. So I see the use in 2D because you're making the line look smoother because of contrasting and adding some kind of gradients. But for 3D, it still becomes a discontinuous surface. So how does the anti-aliasing work in that case?
Well, okay. So I can't talk about the algorithms that go behind achieving the anti-alias result, if you will. But what I can say is that, well, for example, in the SVX format manifest, you were able to define the size of the slice. The bigger the pixel resolution for that slice is, the better final print quality you can get. That's one way to answer it. The other way, I would say, the printers at the moment can handle something around 100 microns. So it's 0.1 millimeters. So you don't have to go to high resolution, actually, as that's the quality that some printers can, that's the maximum. That's the best quality that the printer itself can make. So actually, this kind of super perfect, beautiful design data doesn't have to be so perfect in 3D printing just because of this the resolution limitation at the moment. But so when things get better, you can increase the slice resolution and achieve more accuracy through that.
We should say that we have 5 minutes or 10 minutes to questions. Yeah. So you can ask whatever you want.
So one question is the voxel format would still be an intermediate format.
Yes, yes.
So you still have the original data in in vector format, and then raster format would be just like PCL or any other format that you would go from like an Illustrator to JPEG to print it out.
Yeah, so the ones, okay, so today I showed the Shapeways suggestion for this kind of format, and then what I probably forgot to say that the software Monolith uses a slightly different way for dealing with the data as a format. So that's not decided yet, that's not unified yet. Even if I'm printing something from a voxel file, I need to construct the file by myself, like manually. I have to do the folder structure, write the manifest file by myself, zip it, then change the .zip into .svx. So it's not it's at that stage at the moment.
Is there any like sparse voxel or adaptive voxel format?
Sorry?
Sparse voxel format or adaptive voxel? So when you have big areas of nothing, there's no data there, and once you start getting to the interface between solid and empty space, it starts, well, just say, voxelating, or whatever, further.
Well, at the moment, these format, well, I guess, beta versions of these formats, alpha versions, they don't have anything beyond what I showed today. It's just black and white slices, and if there's a void, it's black, and where there's materia, it's white, and where that shifts into void, you get the anti-alias. So in terms of like adaptive or sparse, there's nothing like that yet that I know of.
For example, they not use PNG, and PNG is compression. So sparse, that's one thing.
I mean, compression is one thing, but yeah, having sparse and then having sublevels at specific voxel entities is different. I know that some games did use that, like progressive meshes and things like that, but...
Yeah, but that would make sense. Yeah, that would be a cool thing to have, definitely. But yeah, it's not yet there, so yeah. Right now it's just 8-bit PNGs.
Actually, that was my question. Is there like, when you set up the file, can you have voxels of different sizes? Like for example, gif compression will create large blocks of the same same color and encode that as one piece of data. If you have, for example, all the outer pixels are one voxel large.
Yeah.
All the inner voxels can be 18, 20, 35.
Right.
And have.
That's something for the future.
That's not yet.
No.
Okay, all right.
No, but I think it's probably a good idea, but it's not there yet. So.
All right.
Yeah.
All right. Cool.
I've been in contact with the guy who has made this format and asked him a bunch of questions, but yeah, it's not there yet. So, and there'll be also other people making their versions of this, I'm sure. So yeah.
The great thing about standards.
Yeah.
Easy to choose from.
Yeah. Because the thing about the old STL, I guess we just kind of got stuck with the STL because back then there was basically only one person who made it, and nobody ever, I guess nobody took another shot at it, so yeah.
Sounds like JavaScript.
Okay. So I don't know if you want to answer this question or if it's too complicated or whatever. it's not about file formats or anything, but you made some comments. So I have no gaming background or 3D rendering, or I don't know anything about ray tracing and stuff like that. I have done some 3D stuff for like CNC milling and things like that, mechanical things, but really rudimentary. But you were talking about like the hood of a car, and you had that diagram, that nice curved thing with the NURBS on it and stuff.
Yeah.
And you mentioned something in passing about like something about the tangent lines and making the light flow smoothly across it.
Yeah.
Is that something you could explain just a little bit?
Okay. So yeah, so in it's not just about cars, but in industrial design, product design, one important aspect when working with 3D is curvature continuity and surface continuity. Let's say that we're making some kind of a well, a car is a good example because it's shiny. So the shinier the finish of the product is, or the part, the more easy it is to see sort of flaws in curvature. And so let's say that we have two parts coming together, and where these two parts are connected, the tangent, the direction of the tangent has to be the same. Well, if it's curved, the sort of the change in the direction of tangent has to be unified. If the tangent suddenly changes too much or too little, you will get a disruption in how light flows, a highlight flows on a surface. So, for example, like products like, for example, like that projector, that's matte plastic. In a matte plastic product, you don't need to be so careful with curvature continuity because there are really no highlights. But especially cars, surface modeling is very, very demanding because you have to pay attention to how the tangent changes along, especially where you have two parts connecting. I don't know. Does that make sense?
It's really interesting.
So, because for example, when people go buy a car, when they go to the dealership, people usually they look at the hood like this, because the lights from the ceiling will project some kind of a highlight on the hood, and people do this, and they look at the highlight, how it flows, and well, from a consumer psychological point of view, you're not going to buy a car where something doesn't look nice. So
as a designer, say you've got your model, you've got the whole car kind of built, and then do you like run some sort of a script that analyzes the continuity of the thing and remove dent?
Yeah, so there are many ways to do that. One, you can, for example, use a thing that's called zebra pattern. So it projects these or maps these black and white lines on an object, and then on the screen you just kind of flip and just kind of rotate the object, just tilt, rotate, and you see how the zebra lines flow along the curvature. Then there's kind of these kind of like rainbow colored, kind of like a finite element analysis, like heat maps, where you can see, okay, there's a dent there. It starts denting, so it goes into a different color, and over here it's red, and green is good, and blue is bad, red is bad, that kind of. So you can see that, but then how to fix it? Sometimes you're better just rebuilding a certain part from the beginning. Sometimes you can kind of save the situation by controlling the NURBS curves that I showed earlier, the different degree NURBS curves. So then you're pulling CVs and pulling control points and trying to save the situation. Yeah. So there's many different ways to do that, but it's not always very fun.
Anybody else?
Just fun fact, nerves was invented by this guy Peugeot specifically.
Yeah, yes.
To make hoods.
Yes.
Cars.
Yes.
Nice.
One more question. You. Sorry. You mentioned you work for industrial design. So what do you use 3D printing for exactly? Is it only for prototyping? And if that's the case, like, do you really care about having a surface really perfect when you do printing in 3D? Or is that more of a problem of like when you go to molding stage and stuff like that?
Yeah, mostly I would use mostly for prototyping. There are some materials like ceramics that you can use for making final products, and some plastics that, like nylon. Some objects you can make in nylon, polyamide, and they look really good, and you could basically sell them as final products. But ceramics is probably best for final products, or porcelain. But yeah, so usually prototypes, especially if it's a product that has a handle, a grip, some product that you're using with your hands, it's good to have a 3D printed prototype for that scenario. Why I care about surface continuity, curvature continuity in that kind of early stage, mostly because I don't want to go back and rebuild things later. So if I can do it correctly from the starting point, I will do it as good as possible. Okay, sketch data is different. You know, if I know that, okay, this is a rough sketch, this is not going to be any you know, no final data is going to come out of this, I will. That's a different thing. But if it's something that I'm going to 3D print as a prototype, the chance is, well, it's a very good chance that I'm already kind of regarding that as potentially final data in my brain. So I want to do it as well as possible from the beginning. Yeah.
So one question, probably is, you know, years out, but you've probably seen where they demonstrated, like research level, they demonstrated that they can actually print colors by controlling the surface area and the way that light reflects off it. So you can, without dyes, you know, you control what color a certain surface will be. This seems like it'd be really well suited to that. Do you know, like, how many years out that might be from where we are now? Or you can just guess.
Well, not just for this, not only for this question, but sometimes people ask me things like, okay, when will everybody have a 3D printer, or when will this thing happen? I think if you're looking at the speed, how things are changing and evolving, I wouldn't be surprised if we're looking at something like that in 5 years.
Cool.
Okay, it could be 10 years, but things are evolving very fast. So while I have no idea, I would say 5 years.
I'll write that down.
Yeah, but I gotta point out another thing. Why it's kind of difficult to do, for example, presentations strictly about 3D printers, what kind of printers are out there, is very hard, because then next week there's going to be another printer out, and then another one. However, Kickstarter is kind of problematic. There are a lot of interesting things out on Kickstarter, but they then have huge difficulties actually bringing them out as a complete product. So, yeah. So, but yeah. Whenever somebody asks me something, I say 5 years or 10 years.
All right.
Cool, thanks.
This is actually not a question, but just a comment on your question about getting colors without dyes. That's typically to do that, you need to be able to control your feature size to a certain whole fraction of the wavelength of light that you're looking at. I think green is about 520 nanometers, if I remember correctly. So we're looking at controlling feature sizes on the order of 130 to 260 nanometers. I don't know how. Does that change your estimate of 5 years?
Not necessarily. Not necessarily.
Would we have to actually, wouldn't we have to have a printer that prints actual, you know, electrons to do that, or can we do that at slightly lower resolution?
You know, I'm just going to do a guess here, a prediction. For that kind of dye-less color printing, it might end up working in a way that there's some kind of infused metal in the object itself. Because, for example, at the moment you are able to color metals by introducing current into them, and a certain kind of acid inside a current. So it might go that way, that you're actually infusing something during the printing process into the product itself, and then probably introducing a current through it or something like that. That might be one way to do it.
Awesome. Thank you.
Right. My question would be 3D printing and product design in Osaka or Kansai. How do I get about it? Whom do I talk to? And if we are going 3D printing, like, yeah, where do I start?
Okay. Well, so I'm a member of Japan Industrial Designers Association, and we have a group of people meeting every now and then, probably right next door. That might be. So there are some meetups through that organization. There are printers available in different academic institutions that are kind of not always being utilized so much. So we have some connections to a couple of places where you can use printers that are normally out of limits for normal consumers, for example. So we can talk. I can tell you more later when the next meetup is, for example.
Awesome.
Yes.
Next one.
I think that's it. Okay, thank you very much.